In this lesson entitled Miscellaneous Equations, we have three types of equations we're going to be working with. First is the higher order factoring problems, second, equations with rational exponents, and lastly, equations of the quadratic form. In our first type of equation, higher order equations using factoring, if you look down here, you notice that the types of equations are higher than quadratic, x to the 4, x to the 4, x to the 3, although we can still use factoring to solve these. All the ones in this section are going to use factoring methods that you're already familiar with to solve these higher order equations. Later on in the semester, we'll learn some more factoring techniques to solve other higher order equations that you can't factor today. But all the ones in this section are easily factored using your skills that you know from previous classes. Let's look at our steps. Step 1 says get our equations in general form, or in other words, set the expression equal to 0. Step 2, I'd like you to factor out the greatest common factor, or sometimes we call it GCF, if possible. Step 3, I want you to factor the remaining expressions depending on the number of terms left. If there are 2 terms, you're going to use a formula, either difference of squares, which is a squared minus b squared, or difference or sum of cubes, which could look like a cubed minus b cubed, or a cubed plus b cubed. If you have 3 terms, you're either going to use grouping or guess and check, or possibly another method that your teacher taught you. If you have 4 terms, you must factor by grouping. Step 4 is to make sure that all the factors are prime. If they are not prime, then repeat step 3. Step 5, set each factor that includes a variable equal to 0 and solve for that variable. If you have a factor that doesn't have a variable in it, for example a GCF, if you have a GCF just a value, you don't need to set that equal to 0. Our first practice problem, 6x cubed plus 21x squared minus 8x equals 0, is already in general form. The expression is set equal to 0. Next, I'd like to see if there's any GCF. Looking at 6, 22, and 8, we have a GCF value of 2. Looking at our variables x cubed, x squared, and x, we have a variable GCF of x. When I divide 2x by each term, I'm left with 3x squared plus 11x minus 4. On the inside of my parentheses, I have 3 terms left, which tells me I need to group or guess and check. I'm going to be using guess and check. I like to list out my factors of a and c. The only factors of a I have to choose from are 1 and 3. On the factors of 4, I have 1 and 4 or 2 and 2. I'm going to choose 2 and 2. I usually like to start with the ones that are closest together first. To check, I multiply across. Can I use 6 and 2 to get to 11? Well, no, I can't. So this is not my factorization. Next, let's try 1 and 4. To multiply across, I get 3. Multiply across, I get 4. Again, that's not going to get me 11. I have one more option I can try. 1 and 3 and 4 and 1. When I multiply across, I'm getting 12 and 1. I can use 12 and 1 to get to a positive 11. That's going to be positive 12 and a negative 1. So my signs come in. And a positive times a negative is my negative 4, which is what I want. Lastly, I'm going to stick in my x values. please don't forget to bring down your greatest common factor. Each of these factors that I have 3 factors here, and each one of them are prime. They cannot be factored anymore. So the last step is to set each factor equal to 0. Each of these factors does have a variable in it, so all 3 of my factors are going to be set equal to 0 and solved. My solution set is 0, 4, and positive 1/3. My next practice problem, 5x to the 4th minus 20x squared equals 0. I'd like to factor out a GCF if I can. It looks like each of those terms can be divided by 5x squared, leaving me with x squared minus 4 equals 0. I have to be equal to 0 in order to use the zero product property. X squared minus 4 has 2 terms left in it, which means it's either a difference of squares or a sum or difference of cubes. In this case, x squared minus 4 is a difference of squares. Which means I'm left with x plus 2 and x minus 2. Each of my 3 factors are now completely factored, or what we call prime. So I set each of my factors that has a variable in it equal to 0. And now I can solve. When I take the square root of both sides, I take a plus or minus part, although plus or minus 0 just doesn't really make much sense, so we're just going to write 0. And my solution set is 0, 2, and negative 2. On the last problem, x to the 4th plus 4x cubed minus 8x equals 32, this is the first time that we don't have it in general form, where the right side of the equation doesn't already equal 0. So I'm going to make it equal to 0 by subtracting 32 from both sides. I first look to see if there's a GCF, and there is not a GCF among all terms. Next, I count the terms, and I have 4 terms, which means I have to do grouping. I'm going to group the first 2 in green, and I'm going to group the second 2, or last 2, in red. Looking at the first 2, cover up the red group and just look at the green group. In the green group, what can you factor out of both terms? Well, in this case, we have an x cubed, which leaves me with x plus 4. Now cover up the green group and just look in the red group. What can you factor out of negative 8x and minus 32? And the answer is negative 8. If you accidentally factored out a positive 8, then the x plus 4 factor wouldn't appear in both the red group and the green group, and then you'd know to go back and factor out the negative as well as the 8. Now that I have the x plus 4 factor appearing in both the green group and the red group, I can factor out the x plus 4, and I'm left with x cubed from the green group and minus 8 from the red group. The next step says, is all my terms factored? Well, x plus 4 can't factor anymore, but x cubed minus 8 is a difference of cubes. So the x plus 4 factor will stay. And then I'm going to factor my difference of cubes. X cubed is x quantity cubed. 8 can be rewritten as 2 cubed. So 2 is my value there. Using my formula, I have x squared plus 2x plus 4. And now each of these factors are completely factored. Each one of the factors are what we call prime. So I set each of the factors equal to 0 in order to solve. The first two are linear, and I can get my solution with some simple operations. So I'm getting -4 and -2. Unfortunately, the third factor is a quadratic factor. So I can either use completing the square or quadratic formula on this problem. It doesn't really matter to me. I'm going to go ahead and practice quadratic formula just so you have another example of that. Although you're welcome to use completing the square, especially because A is 1 and B is even, so completing the square is a good option for that as well. To get my last two solutions, I'm going to substitute A, B, and C into the quadratic formula. X equals -b, which is -2, plus or minus the square root of b squared, 2 squared is 4, minus 4 times A times C. My A is 1 and my C is 4, all over 2 times A. Next, I'd like to reduce inside the radical, which gets me 4 minus 16, or -12. Now 12 can reduce. 12 can be broken down to the square root of -4 times the square root of 3. The square root of -4 is 2i times the square root of 3. A little more space here. So this is giving me -2 plus or minus 2i square root of 3. Each of those terms has to be divided by 2. And my final solution set is -1 plus or minus, these 2's cancel, I square roots of 3. Now that's 2 of our solutions, but there are 2 more solutions. Please don't forget them. I know that was a long time ago, but please don't forget to include -4 as your solution and 2 as part of your solution. So we should have 1, 2, 3, 4 total solutions.